Hello kids, good afternoon, good morning. Today, I'm sorry that I'm not able to be with you, but I prepared this presentation for you to go through your Alex activity without, well, hopefully without any trouble, okay? So we have been seeing different kinds of trigonometric identities in the past couple of weeks. And today we're gonna go through trigonometric identities involving sums and differences, okay? So why are we doing this at the end? Why is this gonna be useful? Well, remember that at the beginning of the course, we used the unit circle, remember? We used the unit circle and we had certain angles that were called the special angles, for example, 30, 45 degrees, 60 degrees, and so on. These angles, it was really easy to calculate the sine or cosine of those angles because we just had to look at the coordinates on the plane of these angles, right? We called these special angles, and we didn't need a calculator to find their sine or their cosine. So our purpose in this lesson is going to be to find a trigonometric expression, a trigonometric ratio of a certain angle. I don't know, one that is not a special angle, for example, I don't know, 78, the sine of 78. It's an example. By using the special ones, okay? That's the whole point, kind of. That's where we're gonna be using the identities for the sum and the difference of an angle, okay? So before I move on, I'm gonna show you the identities that we're gonna be using, okay? So give me just a second. I'm gonna go to the next one. So we're gonna have these identities for the sine function. Our first identity is gonna be for the sine of a sum, okay? In this case, I'm writing sine of a plus b is not gonna be equal. One would think maybe that this would be equal to sine of a plus sine of b, but this is incorrect, okay? So what is gonna be sine of a plus b? The sine of the sum of two angles is gonna be sine of a multiplied by the cosine of b plus cosine of a multiplied by the sine of b. And as something similar is gonna happen when we have a difference of two angles, right? The sine of the difference of two angles. We're gonna have sine of a times cosine of b minus cosine of a times sine of b. So as you can see, these two formulas are almost the same. We have sine, cosine, cosine, sine, sine, cosine, cosine, sine. But in the addition, in the sum formula, we have a plus, and in the difference formula, we have a minus. So they are really easy to remember, okay? So remember, when we have the sign of addition or the sign of a difference, sine, cosine, cosine, sine. If we have a plus in the middle, and then sine, cosine, cosine, sine. If we have a minus here in the middle as well. Okay. Now, as a side note, these formulas can be derived using the definition of the trigonometric functions on the unit circle and some geometric properties. Right now, I'm not gonna show you where these formulas come from because it would take very long, but we're just gonna use them, okay, to solve some problems. Now, we're gonna have a similar thing for the cosine, okay? But look, when I have the cosine of a sum of two angles, our formula is gonna be cosine of A, cosine of B, minus, I have a plus here, and here I'm gonna have a minus. It's different from the one of the sine. So cosine of A, cosine of B, minus sine of A, sine of B. And if I have a difference of angles, it's going to be the same. Cosine of A, cosine of B, sine of A, sine of B, just like in here. But if we're talking about a difference, we're going to add. So it's the opposite. If we're adding, we subtract. If we're subtracting, we add. Okay? These formulas, you're going to have them with you. So you don't have to completely memorize them, but you need to kind of memorize them to learn where you're gonna use which. You're gonna see in a minute what I mean by that. And the last two sum and difference identities are gonna be for the tangent. Okay, these are a little bit more complicated because we are going to have a quotient. Okay, so the tangent of A plus B is going to be tangent of A plus tangent of B, but we're going to divide all of that by 1 minus the product of tangent of A times tangent of B. Okay, so if I have a plus here, I'm going to have a plus here and a minus on the bottom. And then the formula for the difference of angles in a tangent is going to be the same almost, but see, I have a plus here, and in the difference one I'm going to have a minus here. I have a minus in the sum, I'm going to have a plus in the difference. So the signs change, okay, but in essence it's almost the same. Okay, almost the same in the sense that the terms are the same, and we have also a quotient in both of them. Now you might be wondering, how are we gonna use this? Okay, we have our first example here. The first example says we're gonna apply the sum identity for the sine. So first example, it says find the exact value of sine of 129 degrees multiplied by cosine of 29 degrees or 21 degrees, and then add cosine of 29 degrees, sine of 21 degrees. So this seems like a very complicated expression, right? And we have some angles that aren't the ones, they aren't special angles, right? In case you don't remember, which ones are the special angles? Partial 1, 30, 45, 60, 120, 135, 150, 210, 225, 240, 270, 300, 315, 330, 0. Here you have your good old friend that I know you love. We're gonna use it again. Surprise. Okay. So these are not the ones, are not special angles. So what I'm gonna do is I'm gonna change this. I'm gonna transform it to get one of these angles. How? All right, so we have a sum, okay? And we have sine, cosine, cosine, sine, right? So let's go back to our formulas and let's see, where do I have sine, cosine, cosine, sine, and a sum, sine, cosine, cosine, sine, and a sum. So this is the formula that I'm going to use. So that means that my formula can be written on my expression. We can rewrite it as, here, this is my A, this is my angle B, 129 is A, 21 is B. 129 is A, and 21 is B. So according to the formula, this would be equal to sine of the sum of A plus B, right? But A is 129 degrees and B is 21 degrees, right? And we can add those two and we get 150, right? 150 degrees. But oh, surprise, 150 is one of our special angles, right? And we know that if we have the coordinates of that angle, the first coordinate is always going to be the cosine of the angle, and the second coordinate is always going to be the sine of the angle. So in our case, we're looking for the sine of 150, and which is the second coordinate of the angle in the unit circle. So this is going to be equal to 1/2. So how does this simplify this expression? As you can see, I can't, just by looking at my special angles, I'm not going to find the sine of 129 because 129 is not an special angle, neither is 21 degrees. So I make this expression into a new one that involves a special angle. And that's it. Okay. So at the end, I'm just going to get something very, very simple. And this is my answer. Okay. First example. We're going to go to the next one. Okay. So let's look at our next example. We have the product of cosine of 75 degrees and cosine of 15 degrees plus the product of sine of 75 degrees times sine of 15 degrees. So again, we have a sum and we have the product of cosine, cosine, and here of sine, sine. So this reminds me of the sum or the difference of the angles in cosine, right? Of the cosine of a difference or a cosine of a sum. But let's check which one was it. I'm gonna go back to my formulas, and here I have the sum of a cosine. The cosine of a sum, I'm sorry, and the cosine of a difference. So in my case, I had a plus, so we're looking at this formula, okay, right? So we're gonna notice that here we have, in our example, we have, this would be A, this would be B, this would be A, this would be B. A is always the first degree, the first angle, and B is always the second angle. And let's see, since I chose this because we had a plus, our expression is going to be equal to the cosine of A minus B. So this is going to be equal to the cosine of A minus B. And my A is 75 degrees. My B is 15 degrees, which I know to be 60 degrees. And oh wow, surprise, surprise! This is always gonna happen. I'm gonna end up with one of the special angles. If you don't end up with a special angle, then you must be doing something wrong, right? So I'm gonna look at my special angle, 60, And since they're asking me for the cosine is always the first coordinate and the sine is always the second one. So I'm going to use the first one, and it's coincidental that I got the same result as the previous one. It's just a coincidence, okay? 1/2. Why do I need to use the unit circle? Because Alex is going to ask me for an exact expression. I can't use decimal points, okay? Just so you know. So as you can see, I need to really pay attention to the form of this expression and to make sure which identity I'm gonna use. Am I gonna use a cosine identity? Am I gonna use a sine identity? Am I gonna use a sum or a difference identity? Okay. And we're gonna do one more now with the tangent, right? So again, let's look at the nature of our expression. We have tangent of 176 degrees minus tangent of 116 degrees divided by 1 plus tangent of 176 degrees tangent of 116 degrees. So let's look at the expression. We have a plus on the top, on the numerator, and we have a minus at the numerator and a plus at the denominator. So I'm gonna go, remember this, plus minus plus, I'm sorry. So I go to my identities for tangent and I find that here I have plus minus. So I'm gonna use the tangent of a sum, right? So I'm gonna go to my example and I got it messed up, right? Yes, I'm sorry. I'm over the moon. I have a minus and I have a plus on the bottom. So I'm gonna use not this one, but the one on the bottom, right? Minus and plus. So I'm gonna use the tangent of a difference. So this is gonna be equal to the tangent of, well, in this case, this is A, the first one. This is B, the second one. A, B. So it's gonna be tangent of 176 minus 160, right? And these are degrees. This is gonna be equal to tangent of 176 minus 116 is equal to 60. So tangent of 60. And you're gonna say, but miss, well, I can look at my special angle, but I just have the cosine and the sine, right? And I would say, so what? Why? Because you know the quotient identity, that tangent of an angle, right, is equal to sine of the angle divided by cosine of the angle, right? And what is the sine of 60? Well, the sine of 60 is square root of 3 over 2 according to our best friend, the unit circle. And we're going to divide that by the cosine of 60, which is 1/2. I'm going to do the sandwich theorem. 2 square root of 3 over 2 times 1 is 2. I can cancel this out and I'm going to get square root of 3. And that's it. Easy. Easy. It's a gift. Now I'm going to do, you're going to have a different type of problem in this topic. And in this one, you're going to be happy that you're not going to use the unit circle, but you're going to have to look in your mind, in your brain, and look for information from partial 1, okay? Again, but it's going to be very simple. So now, it says, use the information given below to find cosine of alpha minus beta. So what is the information that they give me about angle alpha and angle beta? about angle alpha, they tell me the sine of alpha is minus 5 over 13 and angle alpha is in quadrant 4. And of angle beta, they tell me sine of beta is 15 over 17 and beta is in quadrant 2. Okay, and I need to find the cosine of alpha minus beta. So as you can see, they are giving me information of alpha and beta, but separately. Not about the difference, but about each of them separately. Okay, so how are we gonna do that? Well, if you remember the formula for a difference, for the cosine of a difference, I'm gonna write it here, okay? It is. I'm gonna write it over here. Cosine of alpha minus beta is cosine of alpha, cosine of beta, plus cosine, sine of alpha, sine of beta. Okay. So, look, we already have sine of alpha and we already have sine of beta over here, right? So that's gonna make things easier for us. We just need to find cosine of beta and cosine of alpha. How do we do that? Okay, what we're gonna do is we're gonna draw angle alpha and angle beta. So I'm gonna start with angle alpha. It says that it is in the fourth quadrant. So remember, this is the first one, this is the second one, this is the third one, and this is the fourth one. So my angle alpha is in the fourth one. So it would be here. And remember what we did here? We draw a little triangle, right? But we have that sine of alpha is minus 5 over 13. And what is sine? You should already know this like by memory, but fast. It's opposite over hypotenuse. So this is the opposite side. So the opposite would be minus 5. And the hypotenuse is going to be 13. And in order to find the cosine of alpha, then I'm going to need the adjacent over the hypotenuse. But guess what? I don't have the adjacent, but I'm going to be able to get it. How? Using Pythagoras. And I'm not even going to tell you how to use it because you already know. Pythagoras was c squared equals a squared plus b squared, right? So if I'm looking for the adjacent side, you're gonna use the Pythagorean theorem and you're gonna find that this side is gonna be 12. Okay, you should be able to do this yourselves. So this is gonna be cosine of alpha equals 12 over the hypotenuse, which was 13. And I already have my cosine of alpha, right? Which I'm gonna use on the formula in here, right? I'm gonna circle it. Now I need to do the same, the exact same, but for the cosine of beta. Okay, so I'm gonna do it on a different drawing, right? Over here. And it says that beta is in quadrant 2. So 1, 2. It's gonna be here, right? Beta. And I'm gonna form my little triangle. And we know that sine of beta is 15 over 17, but sine again, opposite over hypotenuse. So our opposite side would be 15 and our hypotenuse would be 17. And I can use the Pythagorean theorem again to find the adjacent side, which is going to be, I already got it with the Pythagorean, is 8. And now I can get the cosine of beta. It's going to be adjacent over hypotenuse. Our adjacent side is 8 and our hypotenuse is 17. Right? That's it. Have I finished? No. Now I'm going to substitute in this formula here everything that I got numerically. So I don't have that much space, but I'm gonna write it over here on the top. Let me see if I can copy this. Yes, I can. I'm gonna put it here. Okay. I'm gonna put it there, and I'm gonna substitute. So, cosine of alpha, what was it? Was 12 over 13. So 12 over 13, and I'm gonna multiply it by cosine of beta, which is 8 over 17. And I'm gonna add sine of alpha, sine of beta, but sine of alpha is minus 5 over 13. Sine of beta is 15 over 17. Okay, great. And I have a mistake here because if you can see, this 8 is gonna be negative, right? Because it's on the negative side of the axis. So I'm just gonna change the sign over here and over here. Okay, so now what? I need to multiply and then add all of that. Okay. So I'm gonna do it quickly over here. I already did it. I just multiplied 13 times 17 to 21. And then 12 times minus 8 was minus 96. And then again over here, 13 times 17 to 21, and minus 5 times 15 was minus 75. And then since I have the same denominator, I'm just going to leave the same denominator, and I'm going to subtract minus 96 minus 75, and I got minus 171, right? If I can simplify this fraction, I do it. But if I'm not able to, this is going to be my final answer, right? This is going to be my final answer, okay? So cosine of alpha minus beta is minus 171 over 221. So it is a little bit long, but it's not difficult. It just has a lot of steps. We're going to do one more for you to be able to work on your Alex activity, right? And I don't know why I put this unit circle here, but in this case, we're not gonna use it in these types of problems. In the previous ones, like this, we used it, right? But in this type of problems where they give me information about each one of the angles, we're not gonna use it. So let's see. Now we're gonna do example 6. Again, it says, use the information given below to find sine of alpha plus beta. And we have information about alpha and beta separately, right? We know that the cosine of alpha is 12 over 13 and it is in quadrant 4. And the tangent of alpha is 5 over 12 and it is in quadrant 1. So before we locate the angles and everything, I'm gonna use the formula sine of alpha plus beta. Let's go and see it. Sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay, so I'm gonna go here, sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And I'm gonna use that. So look, I already have cosine of alpha, and that's it. That's everything I have. So I need to find sine of alpha, I need to find cosine of beta and sine of beta, right? So to do that, we're gonna draw again. We're gonna draw alpha first, and then we're gonna draw beta. So again, I'm gonna start here. I'm gonna draw my coordinate plane. It says that alpha is in quadrant 4, so it is here. And I draw my little triangle, and I know that the cosine is adjacent over hypotenuse. So it would be 12 here, and the hypotenuse is 13. And I need to find, I already have cosine of alpha, and I'm missing cosine of beta. So I'm gonna do it here. So using the Pythagorean theorem, I can find the opposite side. I made a mistake. I said I need to find the cosine of beta, but I'm working with alpha, right? So I need to find I need to find the sine of alpha. So I need the opposite side of the angle, right? So to find sine of alpha, I need the opposite side, and I need to divide it by the hypotenuse, but I don't have the opposite side. How do I find it? I'm going to use the Pythagorean theorem. It's going to be 13 squared minus 12 squared, and I'm going to get the square root of that, which is 5. I did it on my calculator. This is 5. And it's going to be minus 5 because it's in the negative part of the x-axis. Very important. So we have minus 5 divided by the hypotenuse, which is 13. And I already have the sine of alpha, which I needed here on the formula, right? So now I'm going to be working with beta because I need to find cosine of beta and I need to find sine of beta. I just have tangent, right? And that's not on the formula. So I'm going to draw again. It says that my beta is in quadrant 1. Here's my quadrant 1. I'm going to draw my triangle. My angle is beta. And I have that the tangent of beta is 5 over 12. But the tangent is, remember that the tangent is opposite over adjacent, right? So it's 5 is the opposite and the adjacent is 12. And how do I find the hypotenuse? Well, I'm going to use again the Pythagorean theorem. And if you do the Pythagorean theorem, you're going to get 13 on the hypotenuse, okay? I trust that you know how to do that. Now, I need to find the cosine of beta and the sine of beta, as I told you before. So to do that, let's work with our little triangle here. So cosine of beta is going to be adjacent over hypotenuse, right? But the adjacent side here is 12 and the hypotenuse is 13, right? So 12 over 13. 12 over 13. And the sine of beta is going to be 5 over 13. Okay, here I have the ones that I had missing in here. And now I have all of the information that I needed in my formula, so I'm going to substitute. Sine of alpha was minus 5 over 13, and I'm going to multiply that by cosine of beta, which is 12 over 13. And then I'm going to add cosine of alpha, which is 12 over 13 again. And sine of beta, which is 5/13. And again, I multiply these two together and then these two, and we're gonna add them. I'm gonna do it. So I already did it on my calculator, and I get that minus 5 times 12 is minus 60. 13 times 13 is 169. And what else? 12 times 5, 60. 13 times 13, 169. And we have the same denominator, so this is going to be minus 60 plus 60 divided by 169, which is 0 divided by 169. But 0 divided by anything is 0. Okay. So at the end, my result is going to be sine of alpha plus beta equals 0. Okay. My answer is sine of alpha plus beta equals 0. And that is it. Right? So perfect. Hopefully now you know how to use the formulas and how to apply them to each type of problem that you're gonna find in ALEKS. So remember, if you need help with your exercises, you can go back to the video and you can see my process step by step. Okay? Good luck with your ALEKS activity. You're gonna be fine and you're gonna do amazing. And I miss you already. Bye bye. Oh, and I forgot. You're ready for your ALEKS activity 12. So go to your ALEKS activity 12. Make sure to submit your procedures to Canvas, complete. And if you finish before the class is over, you can work on your challenge of the weekend. Well, the challenge is not gonna be for Sunday, it's gonna be for next Wednesday, okay? Because I'm not gonna see you Monday, Tuesday, nor Wednesday because you have take 3D. So good luck and love you. Bye.